Here, once again, is Dr. Nick Begich. Doctor, these are very, very, very serious things. Blocking terrestrial communications. Let's think about that. Why would we want to block terrestrial communications? Well, if there was some kind of conflict, some kind of war, we might want to do it. But that's the only reason I can imagine.
Yeah, that's the premise under which it's sort of unveiled in the course of the patents. We've been very careful to try and keep the documentation in order in terms of laying this out. So we footnote everything very carefully. When you look at the whole idea of knocking out communications, one of the attributes of this system as well is not only can they knock out everyone else's communication, but they can also use the same system while they're doing that to carry their own communications. In other words, they can talk to each other, but no one else can talk to each other. And that would include radio like this, television, virtually all forms of communication, including landline communication. In fact,
you have got to be kidding. Now, for example, I can understand that they could affect the ionosphere. At night, a lot of the radio stations I'm on right now bounce very strong signals off the ionosphere and back to the ground, and that's how people are able to hear these big 50,000-watt radio stations hundreds of miles away. Now, are you telling me they could block that?
Yeah, absolutely. At high enough power levels, of course, beyond the developmental prototype stage, but the full power array system that they envision, that's exactly right. It's similar. The talk recently about the solar event that heads our way and creates disruption in communication, and it creates sometimes can even create power grid failures and so on. Essentially what that is an EMP, an electromagnetic pulse coming from the sun and passing through our system.
As a matter of fact, Doctor, there are bulletins all over the place. There have been 2 X-class events on the sun, which are considered to be the strongest of all that are headed our way.
Right, and this is what you have here is you have something on the ground that's operating essentially in the cavity between the upper ionosphere and the Earth, and so it's working a little bit differently, but it's a controlled, coherent, rhythmic, if you will, signal that's allowing the energy in some cases to bounce, in some cases changing the state of the ionosphere, and others following magnetic field lines that surround the Earth. But whichever application or however they're applying the technology, in the case of communications, it's essentially an artificial electromagnetic pulse. We used to be able to create those with a thermonuclear detonation in the upper atmosphere, or they occur naturally with solar activity.
You mean it could be that strong? Now, I understand a nuclear detonation up high would provide an EMP that would knock out computers, would prevent communications and all the rest of it. And you're telling me that HAARP could conceivably produce an artificial or the same rough effect without the nuclear detonation?
Exactly. And so from a military perspective, it obviously has advantages because you can control it with some precision, as well as you don't have the radioactive fallout that you would get from a thermonuclear blast.
Good Lord. I should add that I already looked. Keith is a fast guy, and if you'll go to my website in the new items right there at the top, you'll see a link. Go look at the HAARP antenna array. We've got an actual picture of it, and a doggone good one, I might add, on the website right now. It is a remarkable sight, Doctor, to look at this array. Now, let's move to another category. Before we begin describing what HAARP really is technically, there is a suggestion it could affect the weather?
Absolutely. In fact, one of the things that comes up in the patents initially is the idea that you could use this for creating a couple different ways, actually. One, by making a hole in the ionosphere, which is one of the stated military uses. What happens is a hole appears, and this hole appears 30 miles where the ionosphere begins, about 30 miles above the Earth's surface, and would extend several hundred kilometers up and maybe be around 30, 40 kilometers in diameter. What happens is lower atmosphere then rushes in to fill that void, and there's a number of uses for that atmosphere being in that place, but what it also does is alter localized weather patterns. Now, this is with a small array. With a much larger array, you can do a lot more with it.
Now, let me understand. The HAARP transmitter blasts a hole through the ionosphere, and you said 30 to 40 kilometers diameter?
Yes, that's the potential, yes, at the first phase.
That's at the first phase. Good Lord. And then the lower atmosphere rushes in to fill that void, and the lower atmosphere, of course, is where our weather is, clouds, winds, whatever. And so it literally sucks the weather up.
More or less. I mean, it eventually restabilizes, as at least they tell us it does. But the idea is what you then have is in the localized area, you have a big shift in the way weather patterns are moving. And in Alaska, where much of the weather for the lower 48 states and Canada originates, I mean, this is a very significant a factor because it can certainly move things around in an undesirable or maybe a desirable way, but we're playing with something that what you affect in one part of the planet is not going to operate in a vacuum. It's going to have a profound effect as things move around in the way the Earth is more or less an interactive system. You can't just do it here and expect it not to have any effect anywhere else.
Well, in other words, if you cause it to rain through some manipulation in Area A, that means that it would not rain in Area B, where it would have otherwise rained. Is that roughly true?
That's a good example. And you know, in fact, there's a quote that I can give that was given earlier this year, you know, much after our book came out, by Secretary of Defense Cohen, talking about weather change. And he was actually lecturing. He was lecturing at the well, let me see. It was a Mahler Auditorium, University of Georgia, on the 28th of April this year, and he said, this is our Secretary of Defense, and I quote, "Others are engaging in even in an eco-type of terrorism whereby they can alter the climate, set off earthquakes, volcanoes remotely through the use of electromagnetic waves," unquote. And what Cohen was referring to was this new class of weaponry that can be used for manipulating geophysical systems. In fact, talking about HAARP in this context, there's another writer, Brooks Agnew, who published an article called Looking Through the Earth, which talks about the Earth-penetrating tomography, the X-raying, if you will, in the vernacular of the Earth, and using this HAARP system. And he suggests that if they hit the specific resonant frequencies that he discovered in his work or in the early and middle 70s, what will be found is that you can, in fact, trigger these kinds of geophysical events within the Earth. And now we have our Secretary of Defense suggesting, in the context of this question and answer period at the end of his lecture in Georgia, that terrorist organizations may also possess this capability. And yet here we have in Alaska a system that's being designed that will operate within the frequency ranges necessary for creating exactly these kinds of events, and will operate in modes that are that fall along that same line. So we're obviously concerned about it. Whether they know this at the front end of the project is a concern to us as well, because this is something they may inadvertently do as a side effect in the course of their experimentation.
How much do they know about the effect that HAARP will have when it's cranked up to full power? And we'll be covering that here in a bit. And how much is guesswork? I know that before we exploded the first atomic bomb, there was considerable opinion that the entire atmosphere might go into a chain reaction and we'd blow ourselves to smithereens. That, of course, did not happen, but they thought it might. And frankly, at the moment they pushed the button, they weren't absolutely sure what was going to happen.
You know, that's I think that's a fair analogy and one we've used in the past. And when you look at this system, the first thing we note is that they don't know. Once they hit certain power levels and certain thresholds, it's beyond anything they've experienced before, and they know that it will throw a portion of the ionosphere into a state of chaos, and then they suggest that energy release, as it finds a place to restabilize, it'll reorganize at some higher level, and they don't know where that higher level is. John Heckscher, who was the program manager on this project for the military, even in a piece of film I saw recently, indicated they don't know. That's the whole purpose of the experimentation. And the view of it, in some of the literature that they've produced, they talk of it as a plasma laboratory in the sky, and that's
great.
That's the mindset going in. So I think that's and that's part of the problem as well.
Well, this reminds me of scientists who are sort of inquiring minds and saying things like, well, let's take a whole bucket full of C4 and put it down here in this earthquake fault zone and see what happens.
I think that's another analogy that could be applied. I think in some instances, however, a lot of these scientists really don't have a clue. In other instances, I think they're well aware, and for whatever reasons, they feel like they can do this safely. What we found, and one of the things that came up with Brooks Agnew's work, which is, again, this earth-penetrating tomography or X-raying of the Earth, he was able to do with 30 watts of electrical energy in the radio frequency, converting it into radio frequency range, was able to penetrate the Earth a couple of kilometers deep and actually demonstrate in 9 states and 26 drilling programs, demonstrate that just as accurately as the drill logs showed, his earth-penetrating tomography method with 30 watts could lay out the strata of the ground, including showing oil fields, gas pockets, and so on, with 96% accuracy.
Was this an on-site application? In other words, he had to go and apply this 30 watts of RF energy directly to the area he was examining?
Yeah, but it covered a very large area. And what he suggests in this is that with the amounts of energy involved in HAARP, if they hit those same resonant frequency ranges at sufficient power levels, he equates it to possibly a couple of things occurring. One thing that he projects might occur is you get this more or less a standing wave that keeps amplifying in energy until energy is released. And what ends up happening is you trigger energy that's maybe in place in the Earth, like along a fault line where there's stress is building up. Mm-hmm. You hit the right resonant frequencies, you could cause that stress to release prematurely or release more energetically than maybe it naturally would, triggering an earthquake. The other thing that he suggests is that when they're running the system, that it might actually, in some modes of operation, act as a shunt or a carrier of current, if you will, allowing the ionosphere to follow that, which is a charged area, for the electrons to discharge through the ionosphere, through that shunt, back down to the Earth. And what he suggests, and this is his worst case, I must say, his worst case scenario, would be as if the largest bolt of lightning in the world were striking the Earth 40 times a second in that spot. Now that's, from his perspective, a worst case scenario, but it echoes of what the earlier statements by our U.S. Senator Ted Stevens when he was on the Capitol Hill in the early 90s pitching this program on the floor of the Senate. He suggested that that's exactly what this system was designed to do, was to shunt energy out of the ionosphere for use on the Earth. And he was quickly dismissed by a lot of people for that. But the fact is, here it is coming full circle, and now someone else is expressing not the wonderful attribute of that, but that there might be some real problems associated with that particular.
All right, Doctor, I'm a ham radio operator, and though I now live out in a very suburban-type area where I don't bother people, hams run a lot of power, not to compare with HAARP, but they run power. And frequently, when you're in a suburban-type neighborhood with homes close by, people are watching their TVs or listening to their stereos, and any little tiny hiccup in the picture, any little unusual sound in the sound system, and they will inevitably go and bang on the door of the ham radio operator in the neighborhood and blame them. And I wonder if HAARP is suffering some of that kind of psychology. In other words, we get El Nino, there's big waves, bad weather, it's HAARP. I've got a headache today, it's HAARP. Communications are rotten today, it's HAARP. Could some of that be going on?
Absolutely. In fact, it's one of the, I would say if there's any discouraging points along the way of trying to get this story out, it's been that. In the sense that, it's a lot of sincere people that are concerned about the project, but making correlations that aren't necessarily there. I mean, is it plausible? Certainly. But is it happening and is it credible? That's something that would really require independent monitoring to know, A, it's firing at the time in which the observances are being made, and B, that those observances are frequent and reoccurring as the system fires within the certain frequency ranges. I mean, that kind of analysis and monitoring is not being done. It's one of the things we've been trying to have happen since we started this. But there's a lot of connections.
All right, Doctor, we're at the top of the hour. Stay right there. Tell us the truth about a project like this. I live in the state of Nevada, pretty sparsely populated. We have the nuclear test site just across from me here. And when I used to live in Las Vegas, the government would consistently assure us that the underground tests that they were doing had no possibility whatsoever of leaking radiation into the atmosphere. None. Absolutely safe, they would say. However, on days when they were going to conduct a test, they would send out a warning that anybody on a high building in Las Vegas should get out of any precarious position they might be in. But even more worrisome, after stating there could be no leak, if the winds, the prevailing winds, happened to be blowing from the test site toward Las Vegas, they called off the test. Now, I always found those assurances and then the reality of the calling off of the test when the winds were going the wrong way to be a bit of a problem. If nothing can leak, then what difference does it make which way the wind is blowing? And I'm not sure which way the wind is blowing with HAARP. Doctor, welcome back to the program.
Good to be back.
Let us explain to the audience, for those who don't know, what the ionosphere is. Now, with a big radio station, a lot of people listening at hundreds of miles of distance, they don't know that there is this ionosphere that it goes all the way around the Earth at about what altitude, Doctor?
It starts at about 30 miles and then goes up several hundred miles high, and it's a energized area, and it acts as a reflector for radio signals, more or less, allowing them to go across and over the horizon, so people can hear this broadcast tonight, for that matter. The condition of the ionosphere has a direct effect also on the quality of that signal. So part of the whole idea of learning about the ionosphere is to learn how to better manipulate and control the processes of the ionosphere, so you can have clear communications. That's certainly part of this HAARP project as well. The thing about the ionosphere is it also is a protective layer. It keeps incoming radiations of various kinds from coming into our immediate environment, like X-rays and cosmic rays and various particle streams.
Yeah, I was going to say, even though it is convenient to bounce radio signals off of, one has to imagine there is a use for it in the greater ecological sense for the Earth.
Yeah, absolutely. In fact, when you think about holes in the ionosphere versus, for instance, holes in the ozone layer, ozone protects us or filters out ultraviolet light.
Right.
If it comes through, we get sunburn and skin cancers.
Right.
On the other hand, the ionosphere filtering out these much more powerful particle streams basically keep everything intact. I mean, if they were allowed to pass freely into the planet, they would alter the genetic blueprint of the planet. They would have profound effects on every living organism in the world. So
really,
it's a very important layer. I mean, what happens there is very relevant. The fact that we're playing with it is one of the things that needless to say, concerns us.
Okay. Ham radio operators like myself transmit signals that bounce off the ionosphere in short waves. Now, we begin with an antenna on the ground that has the various sorts of antennas, there are many, that has a very narrow beam width, very narrow. When we start transmitting, if you can imagine, it's just a very narrow little pinpoint, and as it goes toward the ionosphere, it broadens out and broadens out and broadens out, and so when it hits the ionosphere, it is indeed a very broad signal. Right. And then is reflected back to Earth, and the next time it goes up, it's even broader. So it hits the ionosphere, in effect, very lightly.
Yes, and as it spreads out, as that energy spreads out more or less, what you get is a increase or a decrease rather in power density, which is why the further away you get, the softer the signal. What you have with HAARP is something much different. You have a phased array antenna field, which is nothing unique about phased array antennas except the software and the configuration of this field. And when you look at ART's website, you'll see it. I mean, what happens is they fire the antennas in a specific sequence to create a focusing ability. Using a principle of cyclotron resonance, they're able to focus the energy into a relatively small area. So instead of spreading out with distance, it focuses or concentrates. In the same way, an analogy could be drawn with the way that a light leaves a flashlight. It spreads out very, very quickly and dissipates with distance, whereas through a laser it's focused and concentrated. You could think of this as a radio frequency laser, although it's not focusing quite so narrowly and tightly. The principle is there. It's focusing the energy as opposed to letting that energy...
All right. Should I think of this as a radio signal, that the HAARP signal that leaves the Earth in a laser-like way and remains roughly the same diameter when it strikes the ionosphere, or in fact, does it start out the exact opposite as a broader signal on the ground, which then becomes focused at a very small, relatively pinpoint size when it gets to the ionosphere?
It focuses, it's correct. It's a big field on the ground, and it focuses to a small size. A pinpoint is maybe too much. I mean, that's one of the things that they beat us up for, because we use the expression a point, and in the mathematical sense, that's that infinitely small area. What we're trying to do is illustrate it's focusing it, and then by moving it, by being able to move the array, they can actually steer it the way they can fire it and manipulate it. So even though it's a small area, they can affect in milliseconds the steering of it, so it impacts a larger and larger area by more or less making broad sweeps at a very, very rapid rate, driven by very sophisticated computer software.
All right, and as you said earlier, one of the things it's going to be able to do is to literally poke a hole in the ionosphere, this very important protective layer, poke a hole in it 30 to 40 kilometers in size, literally burning a hole in it, actually.
Right.
And the thinking or the hope is that it will fill back in again after they poke their hole in it.
Right. And the question comes up, and we haven't even breached it, is what do they want to make a hole in there for in the first place?
Well, all right, let's ask. Why do they want to make a hole in the ionosphere?
The thing that we found early on that was interesting is once that lower atmosphere rushes in to fill that space, low-orbiting satellites, if they encounter that pocket of atmosphere, it creates drag forces and actually destroys the object. The other thing that we found more recently, and it was sent to us by one of the largest research institutes in the world, sent us this little blip on new technologies, for instance, for breaking up comets or asteroids and so on, because there's a lot of discussion about that these days.
Oh, yes.
And when you think about a comet enters, for instance, the atmosphere, the thing we all hear about is most of them burn up in the upper atmosphere. You have, as we said, from the lower ionosphere to the Earth, you have about 30 miles.
Right.
If you could, and you can, with a large antenna array used in the manner that HAARP can, you can extend that 30 miles of lower atmosphere, that dense atmosphere. You can push it out another couple hundred kilometers at the same trajectory, at an angle, at the same trajectory as an incoming object. You give more time, almost 5-6 times more time for that object to break up.
That's incredible. Now, if I'm trying to picture this in my mind.
Because it's drag.
You're blowing. Here you are blowing a hole in the ionosphere and literally pushing the ionosphere up, or pushing the atmosphere up. So you're saying if they were to detect an object coming toward us, they could add a couple of 100 miles more of burn time for this thing to burn up. Is that correct?
That's correct. That's the way it's described. And this is by one of the top atmospheric physicists in the world out of the former Soviet Union, which incidentally was doing quite a bit of work with phased array antennas and what they accurately, more accurately than us, call an SDI system.
All right. We also have, in fact, I use every day. I take weather photographs, NOAA satellites, which orbit just a couple 100, 300 miles, whatever it is, above the Earth, and they are called polar orbiters. Now, clearly, they would be in the range. You said the ionosphere goes 30 miles to hundreds of miles up, so they could blow a hole ahead of one of these satellites, and when the satellite hit this denser atmosphere that had been pushed up, it would create drag and bring that sucker down, wouldn't it?
That's correct. That is absolutely correct. And you know, and the thing about it is, when if they're right and it does fill in relatively quickly,
yes,
once you switch it off, there's, you know, it's one of these unexplained events. You know, it's not like a missile hitting it that leaves a trail. You could certainly monitor it with the right equipment, but it's one of these things you can plausibly deny as well. So it becomes interesting as, you know, again, as a ground-based Star Wars weapon system. And the interesting part of that is at the very end of the last presidential election, when Dole was debating the issue of Star Wars and starting to raise that again, he said the cost had dropped substantially. And the reason he said it had dropped is he also said that it went from a satellite-based system augmented by some things on the ground to the opposite. 4 satellite or ground-based systems augmented by satellites in orbit. So you have, with HARP, really a developmental prototype that presents some of that technology for the military. The things that we're concerned about is not so much the defense applications, because I still think we're in a volatile world, but it's the risk factors associated with getting us that capability, and we need to make sure that we're approaching it from...
Well, we'll talk about the biological effects of this. They tried firing a laser at a satellite here recently, and they did fire a laser, a ground-based laser at a satellite, and I have not heard the results yet. Are you privy to those results?
I haven't seen the results, but we've been tracking, you know, laser technologies for quite a while, and you know, there's the testing of these systems that supposedly, you know, if you'd read press reports 3 years ago, they were denying that anything exciting was happening there, and now they're telling us they're doing the tests. And that's very typical of the way these kinds of projects are developed.
So they're still very obviously interested in ways to disable orbiting satellites. Very, very interested. And HARP might be a much better, more efficient, cheaper, and again, effective way to disable a satellite than a ground-based laser, which has to penetrate a very great deal of the lower atmosphere, and that's very hard.
Exactly. And the other part of all of this is when you're talking about technologies, you know, the military follows several lines of research at once. What you have with HARP, and we've touched on just a few of the applications so far, is it's a very versatile tool. It has a lot of different capabilities. It's that variety or that versatility that make it unique. I mean, in the sense of here you have a system that you can use as we said, for Earth-penetrating tomography, for communications. You can also use it for communicating with submarines at higher data rates. You can use it for transporting energy from one place on the planet to another.
Oh, brother.
In fact, there's a...
okay, Doctor, hold that thought. We're at the bottom of the hour again. We'll be right back, Doctor. Nick Begich is my guest. All right. Now, they're up there, many of them, looking at that antenna array. Now comes the really scary part about all of this. As a ham radio operator, I've got a station here next to me. I love it, as a matter of fact, and I run 1,000 watts of RF energy, and that gets me around the world quite handily. Thank you very much. Then you might look to commercial broadcasting, and I've got AM radio stations scattered all over the country, many of them running as much as the legal maximum 50,000 watts. That enables people to hear literally sometimes all the way to New Zealand and Australia and all over the world. So it gives people a sense of what we're about to talk about. I run 1,000 watts. The big stations run 50,000 watts. What are the plans for this HARP project?
The first phase is for 1 billion watts.
1 billion watts.
That's correct. The second phase goes 4 to 10 billion, depending on which of their documents you read. And this is effective radiated power.
Yes,
and then at the very highest desired level, according to one of the technical memorandums we found in our research, their desired level is for 100 billion watts, which is the level of power that John Heckscher on CBC TV in Canada acknowledged it would take to modify weather on a very broad scale. So you're talking about unprecedented, huge amounts of energy, coherent energy that can be controlled on the ground, manipulated in various ways, and create tremendous weapons effects. At the same time, creating these side effects that we've started to.
That's absolutely an unimaginable amount of power. 100 billion watts.
You know, we had a physicist actually look at that and compare it to a Hiroshima type bomb in terms of if HAARP is operating for a certain amount of time, you know, what does that equate to? And I believe that if I recall correctly, it was about an hour of operating time. With HAARP would generate that kind of energy release at its upper power levels in this phase.
All focused very tightly on the ionosphere. That's just astounding. Now, I just recently came back from Egypt. Got a chance to lay in the sarcophagus in the Great Pyramid, and there have been a number of experiments, Doctor, of recent days, acoustic experiments done by scientists, which show that the resonant frequency in the pyramids, in the chamber itself, is approximately 7.8 hertz, which also, coincidentally, interestingly, happens to be the resonant frequency of the Earth itself, roughly 7.8 hertz, something like that. Now, the HAARP project will use some higher frequencies, but I have heard rumors that they may transmit down in this extreme low range. Is that true?
Absolutely. In fact, the Schumann's Resonance, which is what you've talked about, 7.3 was discovered by a scientist in the 50s, and has now coined the phrase Schumann's Resonance, the resonant frequency of the Earth.
Yes, sir.
In fact, right in the middle of our website, it's in our trademark, 7.83 hertz. And what you see in that is that also is the brain frequency of human beings in the alpha state, and in a very good, that particular frequency is extremely good for accelerated learning. And, you know, what we know about HAARP as it relates to extremely low frequencies, ELFs, is that what they do in this situation is they pulse the high frequency energy from the transmitter into the ionosphere, and the pulsing ends up causing the ionosphere to more or less pulse back. In other words, it starts to resonate, vibrate with that incoming pulse. They can even play music and have it vibrate to the music. But when it vibrates, it converts from from DC current to AC current, and becomes virtually like an antenna in the sky, that instead of being a few kilometers long on the ground, it's thousands of kilometers long, and it then sends back to the Earth an ELF signal at the pulse rate. So they can go everywhere from ultra-low frequency all the way up by pulsing and shaping the waveforms on the ground. So it's a very versatile tool. So the ELF then comes back to the Earth. This is what's actually used for the Earth-penetrating tomography application. In fact, the range of frequency for that application, according to the HAARP planners, is 1 to 20 hertz, which correlates to the predominant brain waves of human beings.
Great. All right, so if I understand this correctly, they will fire at the ionosphere this higher frequency, causing it to pulse back, to resonate, and fire back toward the Earth this frequency, which is virtually as you mentioned, the Schumann resonance frequency, or the same operating frequency of our brain alpha brain waves.
Absolutely.
No, okay, fine. So here's what's always scared the hell out of me. If they can take this and cause it to penetrate the ground to great distances, searching for underground tunnels and bunkers, right?
Right.
For whatever reason, they would search for these. That's a whole nother subject. Before it can go into the ground, penetrate the ground, it's got to go through the biological organisms that are above ground, us.
That's correct. In fact, we were very careful when we wrote our book to document each of the these areas so that people could, come through that portion of our writing and understand clearly what this means. Because what happens in the ELF range, and what more and more research is showing, is that you can trigger chemical reactions within the body. In fact, there was a document that we cite called Low Intensity Conflict in Modern Technology that was put together by Maxwell Air Force Base, where they describe the use of a pulsed radio frequency weapon for debilitating troops to the point of being combat ineffective.
How so? I mean, what can it do to you?
Well, essentially, if you can manipulate the brain frequencies of humans, one of the things that you could do is make people very lethargic. You could create a situation where they were disoriented. You could, on a more tactical scale, a similar system, but on a much smaller scale and more directed, you could actually, in the course of that document, Low Intensity Conflict, actually stop a heartbeat. So you're talking about something that you can't...
Wait a minute. You never said that before. You could stop a heartbeat?
With a directed energy weapon of a similar nature, but it would be much smaller and much more concentrated in a closer range device, but the same basic technology is there. And this shows up again in military documents that we very carefully cite, because it isn't, this is all those important aspects. Now, with HAARP, it's operating at a lower power density in terms of what's coming back to the Earth. In fact, let's just assume for a minute that the military, as they've stated it to us, are absolutely correct at the energy level coming back with the prototype, which is the small system they have now.
Yeah.
What they say is the energy coming back is approximately the energy density of the Earth. The only difference is that it's coherent or controlled within this 1 to 20 hertz frequency range. Assuming that's correct, and I personally don't believe that is correct. I think that it's higher than that, but let's assume it's correct. Research done at Yale University through the 80s, actually, the early 80s, by Jose Delgado, who had been there for some decades before, doing work on the effects of energy on the brain, electric current particularly, later radio frequency. And what he found is that energy at 1/50th of what the Earth naturally produces was sufficient to change the chemistry in the brain sufficiently to change behavior, almost as easily as turning on and off a light switch. And he demonstrated this with primates and humans in a laboratory environment using a pulsed radio frequency signal. Now, his research was actually cited in the military documents surrounding these new weapons technologies, and it becomes highly disturbing. There's even newer documents that have come out since, one in particular, New World Vistas, which was put out by the Science Advisory Board for the Air Force, projects even more incredible weaponry in terms of this kind of what they're calling non-lethal applications, things that can disturb people and change the behavior of people without necessarily killing them.
Is it within the realm of possibility that, I mean, things are heating up with Iraq again?
Yes.
Now, let's say everything went south and we got ourselves into another conflict and we got past the point of lobbing these cruise missiles in, which is what we do when we want to punish him lately, and we had to actually have troops on the field, and we had troops on our side, 500,000, troops on the other side, 500,000. You've got a battlefield situation. Tension is building. Would HAARP could it be conceivably used to direct a very, very high energy reflection from the ionosphere to a rather specific point on Earth? And what I'm asking is whether a battlefield force could be disabled or confused or made ineffective at a great distance.
It's interesting, is one of the things that we found in the patent cluster surrounding this project in terms of focusing the energy, which is really important, because for that to work, you really have to focus and maintain the integrity of that focus.
Correct, of course.
Through huge distances.
Yes.
And what they had is 3 patents surrounding the idea of transferring, first of all, converting electrical energy to radio frequency, running it through this array, bouncing it off of a large reflector in space, and then coming back to Earth so that it could be reconfigured back into electrical energy and introduced to the power grid.
Right.
Now, which implies, of course, that you have to be able to control the focus relatively narrowly in order to, to do that.
Very narrow focus, or you'd be burning things up on the ground.
Right. I mean, and at the same time, a reflector that gets hit with a solar wind and moves 1/8 of an inch, when you cover that distance, we know what we can do with getting out of plumb with being off a little bit. This is another risk. I mean, but is it possible? Yes, I think it's possible. The thing that I think is probably more probable, however, is that they'll take the basic knowledge of pulsed radio frequency energy systems and put something together that's much more battlefield appropriate in terms of size and compactness. One of those such devices was actually demonstrated about a year ago on 60 Minutes, creating some controversy, but it really quickly got shut up. I mean, you never heard another word about it. And the problem with it was the side lobes, the energy coming off, not necessarily off the front end of a machine like this, but off the sides, affected the operators as well. So, you've got a lot of energy being generated. One of the things with HAARP that's interesting is this summer they just put, along the Trans-Alaska Pipeline, they put in a new fiber optic cable, and they put a spur over to HAARP so they would be able to have really high data rates communication. And essentially, the unit, the buildings, and the facilities were designed to run remote, and now they have the fiber optic cables put in this summer to allow them full remote.
If I understand correctly, you're suggesting the operation of the unit itself, and it is true that transmitters affect those near them. As a matter of fact, get this, folks, at power levels